With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, so question is, a room has windows fitted with a single 1 meter into 2 meter glass of thickness 2 mm. Calculate the rate of heat flow through the closed window when the temperature inside the room is 32 degrees Celsius and the outside is 40 degrees Celsius. So let us first of all calculate for the first part, then we will move for the second part. So in the first part, what is saying is, a glass is fitted in a room having length and thickness is given as 2 meter and 1 meter. So let us suppose this is given to us is 1 meter and the width is given to us is how much? 2 meters, correct? And the thickness of it is given to us is 2 mm, or we can say 2 into 10 raised to the power minus 3 meters, correct? Now let us suppose the front part of this is maintained at 32 degrees Celsius temperature and the outside temperature behind it is maintained at 40 degree Celsius, correct? We have to tell what will be the rate of heat flow through this glass window. Okay, now we have been given that the thermal conductivity of the glass as 1 joules per second per meter per degree Celsius. The thermal conductivity of glass given to us is 1 watt per meter per degree Celsius. So from the equation of the rate of heat flow, we can say that delta Q upon delta T will be given as Ka into delta T divided by the thickness. The K of glass given to us is 1 and the area of the heat conduction is this area, correct? So it will be 1 into 2 meter square, so it will be 2 meter square into the change in the temperature will be 40 minus of 32 degree Celsius divided by the thickness given to us is 2 into 10 raised to the power minus 3, correct? From here when we calculate it, it will come as 8000 joules per second, correct? So the rate of heat flow from the glass window in the first case will be 8000 joules per second. Okay, so this is our first part. In the second part, what we have been asked is, the glass is now replaced by two glass panes, each having thickness of 1 mm and separated by a distance of 1 mm. Calculate the rate of heat flow under the same condition of temperature. The thermal conductivity of window glass and the air are given to us. Okay, so in the second part, the condition given to us is like this. Okay, so the glass window is now replaced by two glass panes, and those are separated by a distance of 1 mm. Okay, so the length given to us, just a second. Yeah, so the length given to us for every one is 1 mm, correct? So this is the glass, this is the air between them, and this is again a glass, and the length given to us is 1 mm, 1 mm and 1 mm, correct? Now the area of the glass is remains same, that is 2 meter square, correct? Area remains the same, that is 2 meter square, correct? Now in this case, what we see over here is glass, air and glass makes a composite slab that are connected in series. So the equivalent resistance of this will be given as resistance of the glass plus resistance by the air plus resistance by the glass, or what we can say is 2 times resistance of the glass plus resistance of the air, correct? Now resistance of the glass will be given by 2 into the length of the glass or the thickness of the glass divided by thermal conductivity of glass into the area, plus for resistance of air is length of the air or the thickness of the air divided by thermal conductivity of air into the area, correct? From here, take L by A as common, since L is 1 mm common for all and area is common for all. So 2 into L by A, sorry, not 2, just a second, 2 will not get come out of the bracket, so 2 L by A into 2 times kg plus 1 by Ka, correct? Now L is given to us is 1 mm, that is 10 raised power minus 3 meters, divided by area is 2 meter square. 2 by the thermal conductivity of glass is given to us is 1 plus 1 upon thermal conductivity of the air is given to us is 0.025. Correct. Now when we calculate it, the equivalent resistance will come out as 21 into 10 raised to the power minus 3. Correct. Now the temperature difference is same as for the part 1, that is temperature inside is 32 degrees Celsius and temperature outside is 40 degrees Celsius. So the rate of heat flow through this composite slab or the glass-air-glass combination will be delta Q upon delta T is equals to the temperature difference upon equivalent resistance. Correct. The temperature difference is 40 minus 32 upon equivalent resistance we have calculated as 21 into 10 raised to the power minus 3. From here it will come as 381 joules per second. Correct. So the rate of heat flow through this combination will be 381 watts. Correct. So this is our answer for the second part. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.